It looks like we have the, the results. So this is the result of the model comparison node, and we have ROC curves and the cumulative lifts and fit statistics table. If you look at the statistics table, it clearly indicates that the winning model is the one at the top, logistic regression. And the reason is, if I scroll down, the misclassification rate on a validation set, clearly logistic regression can achieve the lowest amount of this. So that's the reason. And if you maximize the output window, you can look at on a validation set other statistics, such as average score errors, the AUC index, and so on. So this can be useful. Then let us look at some of the statistical graphics. I should have not closed the results window. Let me open it again. So here, if I maximize the score rankings overlay, and this is cumulative lift, and basically it's making comparison how good your model is in comparison with a random guessing model. So if I select, if we target top 20% sorted by scores of a given model, say a neural net, I should take a look at this, then we can expect the performance of a neural net will be 1.3 times better than that of random guessing model. So that's how we interpret it. And if I change it to cumulative percentage response, then so this one basically shows the response rate for soliciting the indicated fraction of individuals. So if we target top 20% using a neural net model, the cumulative percent response is 60-70%, meaning that among those we targeted, we solicited, 67% of them, they favorably responded, meaning that they send us checks. Right? So basically, this is the ratio of out of our solicitation attempts, how many turned out to be favorable ones, positive ones. So that's that. So I guess then I close, exit the results window. And what we're going to do next is we're going to correctly reflect the correct the prior probabilities in the population. Only 5% of users, individuals, they are donors, so very low. But the current data set is sort of intentionally designed to be perfectly balanced, 50% donors and the other 50% non-donors. So let us adjust the actual prior probabilities. So select data source, and within the properties panel, select decisions right in the columns. And prior probabilities. Do you want to enter new prior probabilities? Yes. And adjust it. 1 refers to donors. So we're going to change this number to 0.05, only 5%. And then the fraction of non-donors, 0.95, so 95%. And select OK. And before I rerun the model comparison node, I am going to make one small change in our neural net in regards to its model selection criterion by changing it to average square error. Somehow, you have to change sort of manually, when it comes to neural net. Other models, you can just make a one umbrella change from the model comparison node. Somehow, it's not accommodated here. And then within model comparison, we're going to select average square error for selection statistics. And selection table, we're going to use a validation. That's the change. And then rerun the model comparison node. All right, so let me stop. And then in the following video clip, I'm going to talk about the results.